Hi, everyone. Thanks for joining us for the first session of our Python and AI series, Large Language Models. My name is Anna. I'm an event planner for Reactor, joining you from Redmond, Washington. Before we start, I do have some quick housekeeping. Please take a moment to review our code of conduct. We seek to provide a respectful environment for both our audience and presenters. While we absolutely encourage engagement in the chat, we ask that you please be mindful of your commentary, remain professional, and on topic. Keep an eye on that chat. We'll be dropping helpful links and checking for questions for our presenter to answer live. Our session is being recorded. It will be available to view on demand right here on the Microsoft Reactor YouTube channel. With that, I'd love to turn it over to our presenter today. Pamela, thank you so much for joining us.
Welcome, everyone. Very excited to have so many people watching for our Python plus AI series for our very first session in the series. In the English version of the series, we'll actually have this both in English and Spanish so that we can cover two languages. So in this series, we are going to be covering all the fundamentals of working with generative AI and Python, starting with LLMs today, and then going on to vector embeddings, RAG, vision models, structured outputs, function quality, safety, and evaluations. So really trying to give everybody a very good base in being able to work with generative AI, because as it turns out, most developers these days are starting to work with generative AI in our actual, day-to-day software development. So very excited to have you. If you haven't registered yet for the whole series, you can do that at the ACA that we'll post in the chat, and that way you'll get emails whenever there is a new one coming up in the series. Today, we're going to be talking about large language models, and you can grab the slides from this URL that we'll also put in the chat, aka.ms/pythonai/LLM/slides. And these slides have lots of links and lots of information, and you can use these slides for whatever you want. We're going to be covering lots of things about LLMs. What are they, how they work, what different LLM options are there, how do we use them from Python, how do we improve the output from LLMs, what are the popular libraries for working with LLMs, and how do we build full stack applications that are powered by LLMs. So we have quite a lot to cover, and we also will have some time for live questions. So, do post your questions in the chat. I will look at it from time to time to see if there are questions that I can answer. So let's start off with LLMs and how they work. So first of all, at this point, I think everybody has used an LLM. So, there's many places you can use it. You can put your favorite LLM tool in the chat. For me, the one I use the most often is when I use GitHub Copilot. GitHub Copilot is powered by LLMs, and that helps me write code more quickly and get answers to common coding questions. And so that's my number one favorite LLM powered tool. Of course, ChatGPT is a really, really popular one, and I have started to use that more as well for just day-to-day questions. And like last night, I was getting help with Spanish translation, actually. So there's lots of great uses for that. Also, if you go to Bing or another search engine, a lot of search engines now have LLMs built into them. If you're a user of Microsoft products like Teams and PowerPoint and Excel, all of them have a Copilot in them, and that Copilot is powered by LLMs. So at this point, pretty much everyone has used an LLM, I think. The one thing I do want to distinguish between the products and the LLMs, right? So all of these, ChatGPT and Copilot and Bing Copilot, these are all user-facing products that are powered by LLMs, but they are not necessarily, it's not a one-to-one with the LLM. So a lot of times these are built on LLMs, but they've added a lot of additional code on top. So it's really important as a developer to understand the difference between them, because you might say, oh, I saw this feature on ChatGPT. How do I do that with LLM? Well, you have to figure out, was that actually the LLM doing it, or was that something they built on top of the LLM? So just keep that in mind as you're, figuring out how these things work and how to build on top of them. So LLMs. An LLM is a large language model. It's a machine learning model that is so large that has achieved general purpose language understanding and generation. And what we mean by that is that we can use LLMs for a huge variety of tasks. In the past, with machine learning models, we typically had to train models specific for each use case, right? So we would have a model specifically for translation, specifically for summarization, specifically for sentiment analysis, right? Now with LLMs, you can use the same model for all of those tasks and a lot more tasks that you can come up with, right? So like this example here is sentiment analysis, right? If I give the LLM an example and say like, okay, here's a review of a movie, here's the sentiment negative, here's a new review of the movie, tell me the sentiment, the language model can actually output that sentiment, even though it's not specifically a sentiment analysis model. So this is what's really cool about LLMs is that it's really like empowering lots of people to be able to use machine learning that couldn't use it before, because in the past you had to train your own model for doing each task. But now any of us, even if we don't have a machine learning background, can see if an LLM is able to do that task for us. So I love it because I don't have an ML background. My background's in full stack web development. But now suddenly I'm able to build things with LLMs that I couldn't before. And here's a blog. This graph here is from a research paper that we just posted in the chat, where you can see what's really interesting is on the x-axis is how many floating point operations they used while training the LLM. And what they notice is that at a certain point, the ability of the LLM just jumps, right? And it's that point, that's the point at which it becomes an LLM, right? Like, you know, around here, it's like about like 10 to the 24 floating point operations per second, right? At that point, suddenly the accuracy for these different tasks goes from, you know, like 0 to 40 or, you know, 20 to 70, right? Like that's what they observed is that, wow, if we just keep training it and keep giving it more, more data, eventually we achieve this general purpose LLM. And so that was really cool when they discovered that. A lot of people didn't think that that was actually going to happen. They thought like it would just get sequential gains, but instead we just see this jump at a certain point and boom, we've got an LLM. So those are LLMs, and you can read a lot more, you know, in different papers. But now we're going to talk about how they work when we send something to an LLM, and we're going to go through this process shown in this diagram, right? So what we know as LLMs is we give it natural language input, right? We write something in English or Spanish or whatever, and it gets turned into tokens. Those tokens get fed to the model. The model then outputs possible next tokens, and those next tokens, you know, one of them is chosen and then turns into a natural language word back to, you know, English or Spanish or whatever language. So we're going to go through each of these steps so that you see what I mean by each step. So let's say we have this sentence here, monarch butterflies lay eggs on. So the first step is tokenization. And you can actually try out tokenization with the OpenAI tokenizer. We can put this link in the chat. And one thing that's important to know is that there are different tokenizers depending on the model. So once they came out with GPT 4.0 and 4.0 mini, that actually has a new tokenizer, and it's better. It's generally a better tokenizer, especially better across, like non-English languages. So, you know, the tokenization is going to depend on the model. So here we can try, but monarch butterflies lay eggs on. And what we see is how it's broken up into tokens. So sometimes a token is an entire word, usually with a white space before or after, right? In this case, you see the white space before. So that's part of the token. So that's an entire word. Butterflies lay eggs on. Each of these got their own token, but monarch got split into two, right? So it's thought that MON was its own token and ARCH was its own token. So that's the thing about tokens is that you don't know, it's not always going to be a one-to-one with tokens to words. It depends on, basically like how often that word has shown up in the training data and, how, the amount of training data across languages, right? Because you could also do this in, I think I'm going to spell this wrong. So that'll definitely make it. Yeah. Let's see if I improve that. I'm not spelling it very well, but as also, yeah, with typos, actually lots of people do, like, let's do a typo in English, right? If you do a typo in English, let's do a worse typo. Let's see, flies. There we go. Right. So when we do a typo, we can see that here butterflies got split into butter and fla and eyes, right? And many people have typos when they're typing things out, right? So a language model can handle basically any input, but some of the input is going to get tokenized differently than other input, especially if you've got something like typos or, words that it's less familiar with. And yeah, so you can check that out. You can try it in whatever language you're going to be using with to see, to see what the sort of tokenization is. But generally the newer tokenizer, I think they trained it with a more diverse set of language data. The original tokenizer had some really weird things where, like, there was a Reddit username that was a single token, which, like, just is like, you don't need a one person's Reddit username to be a single token. And that was because they had trained that tokenizer with a lot of Reddit data, and the Reddit data was like noisy. And this one person on Reddit, this one user on Reddit had posted quite a bit. And so they ended up having their own token. But that's like, the embedding model for the most popular, LLMs in the world, it shouldn't have a single person's Reddit username as one token. That's not a well-distributed token space. So that's an example of the kind of things they improved when they went over and retrained a new tokenizer for the new models. All right. So that's the tokenization step. And so the next step is sending these tokens to the model, right? And the thing to realize is that we send, multiple tokens into the model. Like here, we're sending 6 tokens in, and then we get 1 token out each time. Each time the model outputs something, it's 1 token. And it does this using this expanding context window. So what you see here is that we start off with like monarch butterfly lay eggs on. And so it outputs the, and then it sends that whole input back to the model. And so then we get leaves, and then we get of, and then we get a white space, and then we get milk, and then we get weed, and then we get plants, and then we get a period. And then finally we have the whole sentence. So each time the model gets fed, the previous context, and it generates 1 token, and then it figures out what the next one is going to be. So that way, when it's generating the tokens, it's thinking not just about the word or the token right before, it's thinking about the entire context that you're sending to it to make sure that that token makes sense in terms of that context. So the interesting thing is, when it comes up with the possible next tokens, it actually comes up with a bunch of possible next tokens. So it comes up with a probability distribution and says, like, okay, well, the most likely token is but milk could also, be a possibility here, or plants, or leaves, or ground. So it'll come up with basically a probability for every possible token, and then you can decide how you're going to pick those tokens, right? And the way we usually pick a token is and change which token is going to get picked is by using parameters like temperature or top P. So you may have heard, especially probably have heard of temperature. Temperature affects how we're, what that probability distribution looks like and how we end up picking the next token. And there's this really cool visualization that actually shows you actually how an LLM works. And it even shows you the matrices inside, because ultimately an LLM is doing matrix math inside. So there's a whole explanation here that you can go into if you're curious to understand more about the matrix math. But what I like here is that it shows you the probabilities that come out from this. So we can see, like, okay, this, the most possible one is visualized. And then as you change the temperature, if we change the temperature up, way up high, then what you actually see is that actually this is really cool also, because this gives you an intuition for how temperature works. So when the temperature is low, then it is, we often say it's not as creative when it's low. And what it really means is that, it's saying visualize is the most likely one, right? Let's see. Yeah. So it says visualize is 81% likely. So that means, 81% of the time it's going to say visualize, right? And, that's probably the answer you want if you want it to be a really, really, accurate response, if you're trying to get the most likely response. Now, see what happens when we increase the temperature. What you'll see is that the probabilities of the other options get closer to the probability of visualize, right? So that's what happens when you increase the temperature, is actually flattens the probabilities more, so that some of the less likely ones then become more likely. So that's what temperature does. And then top K will decide basically what probabilities it even considers, right? So you can get deeper into the options there. So this is a really cool visualization, and I recommend digging into more and even reading through it if you want to understand more about exactly how LLMs work. So the point is that in the end, an LLM is a next token predictor. Okay, we take in natural language input, we turn it into tokens, we give it to the model outputs possible next tokens, we pick one, and we get the natural language out. So that is all they're doing, is predicting next tokens. But with that prediction, they're able to produce really, really impressive output. And so, some people say that LLMs are thinking or reasoning, or, or do we have like AGI, like general intelligence? We don't really know. What we know is, like, this is how they actually, like, this is what they're doing, is they're predicting next tokens. The way, what's going on inside the neural network when they're predicting next tokens maybe is similar to the way humans think, maybe, or maybe it's completely different. We don't really know, right? Because we're still not entirely sure how humans work. we somewhat know, but we're not sure. So, they are next token predictors. As to whether they're also thinking or reasoning, I actually can't say. I also can't say whether humans are thinking or reasoning. I did see the question, how does it know when to stop? Yeah, that's a good question. So let me just keep generating with this one. So hopefully you can see a stop token. So usually there's a stop token. And when it gets to the stop token, that's when it would stop. I don't know. I think this one will have, maybe this one just uses a period as a stop token, but like in the GPT LLM, I made the K really crazy here. Let me do a smaller temperature. Enter up to 12 words. Okay, I went to the max. But basically, the way it knows how to stop is that there are stop tokens, and the stop token is a special token. And when it sees that stop token, it stops generating. The other time it might stop is if you specify the maximum number of tokens and you've gone over that maximum number of tokens, then it's going to stop. So it's either going to stop when it sees the special stop token, or when you've gone to the maximum number of tokens. All right, so now let's talk about what LLMs you can use. And, first we're going to start with the hosted LLMs. So these are ones that are hosted on some company's infrastructure, and that you're going to access using an API, like using an HTTP API, using a network call to the API on that company's infrastructure. So obviously OpenAI.com, they were the first ones to come up with these hosted LLMs. So they're probably the most well-known, right? And so these days, probably GPT-4o is the most popular model from them. GPT-3.5 is kind of legacy at this point. So most people move over to the 4o series, or they also have the 03 mini, I hear, is a good one, right? So they've got the O series now, which is what they call the reasoning models. On Azure, we have all the OpenAI models. We also have a bunch of other models. We've got meta models, Cohere, Mistral. We've got DeepSeek. I saw a question about DeepSeek. We do have DeepSeek. So Azure AI hosts a huge number of models that you can try out. GitHub Models has a subset of those Azure AI models that you can use for free. So that's what we're going to be using today, because it's super exciting that you can use them for free up to a certain rate limit. And then, of course, Google has models as well. We're not going to be using those because, we're on the Microsoft channel here. So we're going to be telling you about the stuff you can use for Microsoft and Azure, but they definitely do have some well-known models in the Gemini series. Anthropic is also another one that's well-known for having some really powerful models like the Claude family that a lot of people like to use for GitHub Copilot. So we're going to be using GitHub models today, but you have lots of options for what LLMs you can use. So let's check out GitHub models, and we'll post the link for this in the chat. So what I do is I go to the GitHub models marketplace, and then I can select one of these models. So you can see we've got OpenAI, we've got Phi, we've got Jamba, Cohere, Llama, DeepSeek. I saw there was a question about DeepSeek v3. I feel like, did this just come out? I think this is really new. Okay. Let's see if I can trick it into saying if it's sunny here. I think it'll, there we go. I don't have real time. Very good. All right. Who painted the Mona Lisa? Sometimes I ask it this, because you would think a question like this would be a really straightforward answer. And oh, that was actually really quick. Okay, so that one's pretty different from R1. Let me go back to R1. That was my first time using V3. Who painted the Mona Lisa? Is it going to show us the thinking? Okay, so this one shows us the thinking blocks. That's what I wanted to see. So maybe the new DeepSeek doesn't show the thinking blocks. So I think it's really interesting to see the thinking blocks. And because you see, it actually goes through a long process to try and decide that definitely the one that, the person who painted the Mona Lisa was Da Vinci. And then that's the end of its thinking block. And then it actually answers the question here. So you can try out a lot of models here. And that's what's really cool, is that you get to try out all these models without having to set up anything up. You just need to have a GitHub account. And then you can use them. Okay, so someone points out that R1, the R stands for reasoning. And so that's why it's the one that has the thinking blocks. That's the one that I find really interesting, because I like to see how things, even we don't really know, is this really thinking, or is it just predicting the next token of what thinking would look like? But then at that point, what even is the difference, right? We can also do, a more, standard one like GPT-4o, and, get back a response here. So this is free as long as you have a GitHub account. There are definitely rate limits to it. So you're not going to be running any sort of like batch scripts on it. You're not going to be like actually running your app on GitHub models. But in terms of learning how to use these models and experimenting and prototyping, they're just really quick to get started with. And that's what we're going to be using throughout this series, so that you are able to follow along and actually try this stuff out yourself. Now, another option is local models. So local models are models that have open weights and can be run on personal machines. Local models also have a big overlap with SLMs, small language models, which is a model that's smaller, approximately less than 100 billion parameters. But the thing is, like, an SLM isn't an exact thing, because what's small to one person might be big to another person, right? Depending on the machine. So for me, I have a Mac M1. It only has 16 gigabytes of RAM. So the biggest that I can run is like an 8 billion parameter model. But other people have better machines and they can run like 70 billion parameter models, right? So at what point are they actually, small language models versus large language models? Like, the lines are really blurry there. But you will hear the term SLM, and generally it means something that can run on a personal machine, or maybe like run on a Raspberry Pi, which opens up new use cases for it, right? Now, there's various ways you can run local models. So I like to use Ollama. There's also Llama File and LM Studio. So these ways of running local models will all use tricks in order to be able to run it efficiently on your hardware, right? So depending on whether you have a CPU or a GPU, or on a Mac, if you have an NPU, they'll use every possible trick in order to run them efficiently. And then, there's lots of different SLMs that you can actually run on, on your machine. So, and for this part, of course, we have to demonstrate Ollama, which means I need to put on my llama ears here. All right, so I've got Ollama running on my computer already. You can tell because there's a little llama up there. And so I can say Ollama list, and I can see what is running here. So I do have a DeepSeek R1 8 billion parameter. I've got a Llama 3.1. I got Llama 3.2. I got a Phi. I've got an embedding model, and I've got a vision model. So my favorite is actually I still like the 3.1 from Llama more than the 3.2. So we say like, okay, what was the question we had? Oh, what's the difference between with wyverns and dragons? This was a question my 5-year-old had. Let's see if Llama 3.1 knows. Now, what you'll notice is that this does take a little bit of time, right? This is actually running on my machine. My machine is not a very good machine. So it's generally actually going to be slower than sending a request to a hosted model. A question that sparked debate amongst fantasy enthusiasts and stories and linguists for centuries. All right, we got worms or wyverns, two-legged. Yeah, that's what I, two-legged. Okay, it gave us actually a pretty long response here. So there we go. So, so if I want to, I can use a language model locally, and you can use it actually for quite a few use cases, right? To help with writing, to do some summarization stuff, to, help write your social media posts. Like, I don't know, there's various things you can do with these local models, especially if you have more powerful machines and you can run the larger models. All right, so that's Ollama. So that's another option that you could use for following along today. If you have Ollama installed and you're keen to try it out, just remember it's going to take a little bit longer because it is running on your actual machine. Okay, that concludes the Llama part. So now we were going to look at using LLMs from Python. And, there's various packages that you can use for using LLMs. We are going to be focused on using the models that are hosted on GitHub models. And the GitHub models are actually the same as Azure AI models. So when we're using those models, there's 3 main Python packages that we can consider using. The first one is the official OpenAI package. And that one, obviously supports OpenAI.com models. It also supports Azure OpenAI models, and it supports any models that have an OpenAI compatible API. And as it turns out, a lot of models have an OpenAI compatible API because that API was like the first LLM API that came out, and kind of everybody copied it because it worked pretty well as an API. And that way, even if you're not using an actual OpenAI.com model, a lot of times you can still use that OpenAI package as long as there's a compatibility layer. Then they also have Azure AI Inference, and that can be used for Azure OpenAI, GitHub models, or Azure AI models. And then there's Azure AI Agents, which is a new package, which is specifically for using with the Azure AI Agent service, which is like a hosted agent service. So we're not actually going to be talking about this during this series because we're going to have a whole agent series in the future. But I wanted to put them all here so you had them in mind when you're working with Azure and GitHub models. And we'll also talk about wrapper packages like Langchain later on in today's stream. So to get started with the OpenAI package, you install it usually using pip. So you can be pip install OpenAI, and that will bring down the package. And then you can use that to do chat completion requests, to generate vector embeddings, even to do like fine tuning, all the possible things you can do with that OpenAI API. And I was saying we can use it with many models. So we can use it with OpenAI, Azure, GitHub models, and we can even use it with Ollama. So Ollama actually has a OpenAI compatible API server that it runs. So as long as I've got Ollama running, then I can hit up its OpenAI API compatibility server. All right, so for today, we're going to be using this repo that has lots of demos in it. And what I recommend is opening it up in GitHub code spaces. So if you use this link that we'll put in the chat, what it'll do is it'll bring you to this link about creating a new code space. and you just click create code space here. And that will start up a code space in your browser. So a code space is basically a VS Code that's in your browser that's running a containerized environment, which has everything set up in it. So that way you can get started and you don't have to install anything. Because I see there's some like chatter in about like, oh, how hard is this to install? And I definitely recommend you try installing Ollama because it's really fun and great to have it locally. But if you want to just quickly follow along today, then the easiest way to do is create a code space following the link that we put in the chat. And I've got mine open here already. And so this is what it looks like, right? It looks like VS Code in the browser. I'm using light mode, but if you're using dark mode, you should see it in dark mode. And everything should be set up. You do need to wait a few minutes. So it takes a little bit of time to build the container. And then also it takes a little bit of time to run the installation of all the requirements. But then, after about like 4 minutes, it should all be set up and then you can start using it. So this has a bunch of demos that we'll go through in order to understand how this API works. So we're going to be making calls using the OpenAI package. And that means, what we do is we start off by importing OpenAI, right? That brings in OpenAI. And now all of these examples are set up to work with either, GitHub, Azure, Ollama, or OpenAI. So they've got this if in all of them, which sets it up in each of the ways. So we can look at here. If you were doing openai.com, this is what your code would look like, right? You would use the OpenAI constructor. You'd pass in your API key from the environment. And that's it. Then you have a client. If you're doing Azure OpenAI, it's a bit more work. It's a lot more work. But this is, what your code would look like. Especially this is if you're doing keyless authentication, which means that you don't have to store keys, which is always nice because storing keys is always risky. You can leak your keys. So we've got some documentation here about how keyless connections work. So this is what it looks like for OpenAI.com or Azure OpenAI. So when you're writing your apps in production, you're going to be using one of these ways of setting up the constructor, right? Depending on whether you're using Azure OpenAI or OpenAI.com. However, for today, since both of those require accounts, right? This one requires an OpenAI.com account and this one requires an Azure OpenAI account. We're not going to go through that effort. We're going to use the easier ways, which is Ollama or GitHub. So for that link we gave you, that is setting up GitHub models. And for GitHub models, what we do is we set the base URL. We say, hey, there's an OpenAI compatible server at this base URL. And here is my key for that server. And that key is a GitHub token. And if you're in GitHub code spaces, you already have a GitHub token. Every time you open a GitHub code space, that GitHub token is set for you. So you don't even have to generate this. If you're going to run this locally, then you have to go and generate a personal access token from GitHub. But if you run it in code spaces, that will already be there. Now, here's also the Ollama option. If you did want to use it with Ollama, this is the Ollama local OpenAI API URL, and it doesn't care what key you pass in because just a local server. So here we can also see them in, in the repo here. There's actually, I see a question about Azure versus OpenAI.com. So Azure OpenAI has a bunch of differences. One is that I'm using keyless. So this is the token provider. If I was using keys with my Azure OpenAI, then, then I could do this and then I wouldn't need to do that. The other difference is that Azure OpenAI has a notion of the API version that you need to specify. So for Azure right now, like this is one possible version. There's an API version page, and that's just because Azure has a versioning scheme for APIs. Hopefully, eventually we just bake that into the package so that you don't have to worry about setting it yourself. Then there's an Azure endpoint, and that's like the base URL. And then you also have a deployment name different from a model name. So right now there's a number of differences between Azure, OpenAI, and OpenAI.com. But you know, we have everything set up for you so that if you did want to do it, you can use that code. I was saying today we're going to make it easy and use GitHub models, where we just have to specify that base URL and pass in our GitHub token as the key, and that'll get sent to that URL and it'll work that way. All right, so the next step is to use the chat completions API. So this is generally the way that we interact with LLMs, is that we send it basically a chat. We send it a sequence of conversations. And that conversation starts off with a system message. And the system message provides like the overall guidance and say like, okay, you're a helpful assistant that makes lots of cat references and uses emojis, right? Whatever the overall guidance is for what this LLM is going to do. And then we send in the user message, which is the specific request that you have, what the task you want it to do. And this is a sequence of messages. So you can also actually send in like a whole conversation too. But we'll start with just a system message and a user message. We're also specifying the model name. So in this case, we are using GPT-4o. So that's going to be the model we use. Temperature of 0.7. Remember, that's affecting what token it selects. So 0.7 is considered on the more creative side. N equals 1 means we only want one response. I've never wanted more than one response. Well, I feel like I should just use the default, which is 1. So there we go. So let's try running this. All right, and we got a response. And he says, whiskers twitch with hope, tuna dreams dance in his eyes, empty bowl meows, with some emojis. So there we go. So that worked, and that was going to GPT-4o on GitHub models. So that was a chat completion request. Now, the next thing we might do, like imagine if we said like write an essay about a hungry cat. Like we'll say like write a 5-paragraph essay about a hungry cat who wants tuna. And then I do this again, right? And what you'll notice is that it's taking longer. So the longer the output we request, the longer our API call is going to take, right? Like it's like la la la, we're waiting. Okay, so we finally got it, right? And it looks good. It's got lots of emojis and meows and all that. The tale of whiskers and the elusive tuna. But it took a long time to see that, right? And if this is a user-facing application, users, we get impatient. We want responses as soon as possible. So that's why we typically use streaming when we're building user-facing applications. So streaming means that as soon as we get a token, we show it to the user. And we're able to do that with LLMs because remember, LLMs are actually generating token by token. So as soon as a token is available, it gets sent back through that API call and we can show it to the user. So let's see, please write a 5-paragraph essay about a hungry cat that wants tuna. And so the difference here is that I've said stream equals true. So I've requested it to be a streaming response. And that way, when I go through the response, before here, I just got the response, from inside the Python response object here. But when I'm streaming, I use a for loop. And this is actually, it's going on a generator. There we go. Copilot knew this is a generator, right? This is what's called a generator in Python. If you haven't used generators before, I recommend looking on realpython.com because they have good tutorials about generators. But we're using a generator and we use a for loop to go through that generator. And what we do is we look at each delta, which is it contains each token that streams back to us. And we can print out each of the tokens from each delta. So let's try that one. And here we go. What you can see is it's streaming. So see how we can actually see the words coming in. It's going pretty fast. So, maybe it looks like a couple things at a time, but it is basically going one token at a time. And that's generally what we want to use whenever we're making a user-facing application, so that the user has a better experience, faster experience, and they can start reading as it comes back. And it also makes it seem kind of like, the LLM is, typing, because it's kind of at typing speed here. We can also like make sure that it's at typing speed with how we render it in a front end too. Okay, so that is streaming. And I see some questions about code spaces. Won't be able to like debug code space issues here, but I will have office hours later in the week to help debug anything. And yeah, if here is the repo that we're using. So this repo is always available. So you can also try this at any time. And you can also try this locally if you want to try it with Ollama. I see also a lot of questions about like how powerful a machine do you need for Ollama? Like, as I was saying, like I'm on a Mac with 16 gigs RAM. It's not a super powerful machine. It has an MPU, not a GPU, slightly different. And I'm able to run up to 8 billion parameters, right? So it's really going to depend on your machine and what model you're trying to run. But it's always worth trying it out to see what you can actually do. All right. So there we had streaming. And we could also do, let me just show history, right? So a lot of times, I was saying we can send in a whole conversation, right? Here, let's see, I'm a teaching assistant helping with Python questions about LLMs. Okay. Let me run this. So here I'm using a while loop in order to actually continually get input from the user. Like, okay, what do LLMs do in one sentence? I just want a quick response here. So I get back a response, and then I append the response to the conversation. And this time I use role assistant, right? So generally in a conversation, you're going to have the system message, then a user message, and then typically an assistant message if you're doing a whole conversation. So it'll be like system, user, assistant, user, assistant, user, assistant, user, assistant, right? Okay, and then are they open source, right? And so I append that to the conversation. And so then each time that we're calling the LLM, we're actually sending it the entire past history so that it can see what was, answered before. And that way you can look at context, right? So I said, are they open source? And I didn't say what I was talking about. I just said, are they open source? So it needs to see the full conversation to know that they means LLMs, right? Otherwise, they would have no idea what I'm talking about, right? So that's the important thing when you're doing a whole conversation, is that you're going to you want to make sure that LLM can see everything that came previously so that it can figure out exactly what the user is talking about. So LLMs, pros and cons. As we see, they are creative and they're really good at patterns. They're very good at syntax. So they're very fluent with natural language. They're also very good at programming languages, right? Very good at Python and Java and JavaScript and all that. Really good at React, actually, if you're doing any full stack web development. So they're really good at all these things. The cons is that sometimes they're too creative, depending on what we're trying to use them for. They can make stuff up and they don't know when they've made stuff up, because remember, they're just next token predictors. That's it. So they don't know whether that token is actually correct or not. They have a limited context window. Nowadays, the context window is how much input you can send to it, how many tokens. We started off with really small, like 4,000. Now we're up to like 128,000, which is actually quite a lot. But it's still true that the context window is limited. And also that the more you send, it takes more time and more money. So we're going to talk about ways to improve LLM output. There's various ways here: prompt engineering, few shot examples, chain calls. Those ones are all covering today. There's also RAG, which we're covering in the March 18th session. There's function calling and structured outputs, which we're covering in March 25th session. And then there's fine tuning, which we're not covering in this series, but you can read more about if you're interested. So let's talk about prompt engineering. You probably heard of this before. This was really big. Everyone talking about this when they first come out. Basically, prompt engineering is just changing what you're sending to the LLM, right? So here, let me go back to my code space. right? So here I'm telling the LLM that it needs to act like Yoda, and I'm giving it all these instructions about, what it means to act like Yoda, right? And so then if I run this, I get back a response and it sounds like Yoda. Use wisely, you must. So that's prompt engineering. And, it's just changing the prompt. But the cool thing is there's actually you can achieve a lot of results by tweaking the prompt. And that's the first thing you should always try is tweaking the prompt, right? Giving it very clear instructions about what you want and what you don't want. So we always start with prompt engineering. The next thing we can do is to provide examples. If we're trying prompt engineering and we're still not getting good results, our next approach is to provide examples to the LLM. And this is what's called few shot examples. And we pass it in as a conversation typically. So we say okay, here's an example. If the user asked this, I want this answer. If the user asked this, I want this answer, right? And, we send as many few shots as we need in order to get the better quality. But we have to keep in mind, when we do this few shot examples, it's going to take more time and it's going to take us more money. But this example here, this is a few shots. This is where I want the assistant to be a helpful tutor that does not give the whole answer and only gives a hint or a clue. And it really needed examples to do this because LLMs really like to give the whole answer. So this was something where I needed to do examples, right? So here I give an example of a question the user might ask, and then a hint that the LLM could give. And then I have a new question from the user here. So I send all that in, and then I get back a new hint from the model that doesn't answer the question, but does give a hint. So it has looked at my examples and has copied it. So that's few shot examples. And that's the next thing you should do if you're not getting a good response from just prompt engineering. The next thing you could try is chained calls. So if you're not getting a good response from just a single LLM call with few shot examples, you could decide to do multiple LLM calls and have LLMs, reflect on, whether that response was good, kind of iterate on something, right? And there's different kind of techniques for change calls. There's one called React is one technique, and you can read about them. I think in the Langchain documentation has a lot of these chain calls techniques. But the basic idea is you can chain calls together, and you could use the same model for every call. You could use different models, right? So here's an example where I'm basically doing, first asking an LLM to explain how something works, then asking an editor LLM to review and provide feedback, and then finally asking a writer LLM to rewrite it, right? So we're going through three stages: is generate the original, provide feedback, and rewrite it. And and we could get better results this way. So we can try this out. And we can see it go through steps. And the interesting thing is that you might be able to use cheaper, smaller models for some of these steps. And then, save your more expensive models for only the step that you needed in, right? But this definitely does take more time because now we're doing 3 calls to the LM instead of 1. So, for me, this is often a last resort because I don't want to have to take up additional time, especially if I'm making a user-facing application, right? So you can see it went through multiple steps. This was from the first call. This was from the second call. And then this is the third call here. All right, so that is chained calls. Okay. And I'm going more quickly now because we do only have 10 minutes left and we do have a few more things to cover. And so we won't be able to answer every question live here today, but saying we do have office hours later this week as well. So let's talk about a few popular LLM libraries. There's so many Python packages that have abstractions for working with LLMs. So you might call them an orchestrator package, a wrapper package. They're called agents package. All right, they're called lots of things, right? The one you probably know that's the most famous is Langchain. There's also Llama Index. Newer one is Pydantic AI from the people who created Pydantic. There's Semantic Kernel from Microsoft. There's AutoGen, also from Microsoft, from the research division. And there's Light LLM. So these are all packages that, you might consider using. We've got examples here that connect with each of these packages, right? And what you'll see is that, there's a lot in common across the packages, and there's also big differences, right? So with Langchain, we connect to the model, right? This is how we can connect to GitHub. You could also connect to Azure if you're doing this for Azure OpenAI. Then we pass in our conversation with the system message and the user. And then Langchain does this thing where it chains things together using the pipe operator, and then finally invokes the chain, right? So that's the Langchain way. That's how it generally looks. And Langchain has also a bunch of related packages there. So you can try out that one if you want to see how that works. Llama index is really similar. We connect to our OpenAI provider, we pass in the conversation, and then we execute that conversation and get back a response. Pydantic AI also looks really similar. In this one, Pydantic AI, you construct an agent. An agent just has an associated system prompt, and then you pass in your users to it. And yeah, so there's many different options. I actually usually don't use any LLM library at all. I just like to use the OpenAI SDK just on its own. But there are many people who do like to use LLM libraries. So you need to decide, for yourself whether you want to use an LLM library. Here are some of the things to consider, right? The big thing is is it going to support every LLM and host that you need? And also, can you use it the way you want to use it, right? So for example, there's some of them like Light LLM does support Azure OpenAI, but only with keys. It doesn't properly support the keyless option, right? So that's a big thing to look at is what possible LLMs are you going to use? Can you use it with that package? Does it support all the features you need, right? Do you need streaming? Do you need function calling, right? What are all the things you're going to need in your app? So you want to think about that. How easy is it to use and debug? That's a big thing, actually, because it's every time you add another package, especially a wrapper package, an orchestrator package, it's going to be like more layers of functions on functions and classes, right? And that means it can be harder to debug because you're going to have to go through all these layers of the library in order to get down to what's really happening. So I think debuggability is really important for a framework. And that to me is one of the reasons that I often don't use frameworks. Security issues. This is a big one, actually. Some of the frameworks I just showed do have some security issues, especially, the ones that deal with have SQL commands in them, like the ones that have vector stores. So you do want to think about security issues, right? As soon as you're trusting somebody else's code, you want to run that through a security scanner, make sure you're comfortable with any errors that come out, make sure that it's not going to subject you to SQL injection or leaking keys and all that stuff. And then is it actively maintained, right? So, you want to use something that's up to date. All the ones I just showed are still actively maintained, but lots of AI packages have come and gone. So, you want to check to see how frequently is it being maintained? What's the kind of vibe like in the community? How responsive are people in the issue tracker? That sort of thing. And generally, whenever you're picking a library or framework, it's always about, are the trade-offs worth the benefit? If you think you can go a lot faster with that framework and achieve everything you want to achieve, then great, it's probably worth it. But if it's going to hold you back, if it's not going to be flexible enough, if it's going to have too many issues, then, probably not worth it. So you have to decide for yourself. All right, so finally, we're going to talk about building LLM-powered apps. And this is the final section. I know we've covered a lot today, and we'll probably get feedback that we need to split this one into two. I will say we already split this one into two, but this is what happens is we always find new things that we want to talk about. So if we need to split this into two in the future, we totally will. So building LLM powered apps. So here I'm talking about building full stack web applications that have LLMs that are powering functionality from them. And the example that I'm showing today is this repo here, and we'll post this in the chat. And this is actually a chat plus vision app. So we're also going to visit this again in the vision models section. But I'm showing it today because it does work with GitHub models. So let me go ahead and open my code space for that. So once again, you can open it in a code space. So if you go to the repo and you click on code, then you can create a new code space. and open in the code space and use it with GitHub models. So here I'm loading up the code space again. I'm using GitHub. So I set my .env to use GitHub. So that's set up there. And then I can run the application and show you what it looks like. Let me look. Okay, so here's the command to run it. All right, so this is running let me make this bigger. This is running a court application with a very basic front end. So this is going to open in the browser. I want to say, write a haiku about llamas who love LLMs. Okay, put llama ears back on. There we go. Let's make this bigger. All right, so this is working, and this is working with GitHub models, right? So let's just talk about the basic architecture of this application to give you an idea for what a full stack application looks like that is powered by an LLM. So on the front end, this one has a very basic front end. It's just HTML and JavaScript, right? It's just, if we go here, we can look at the templates, right? So this is our HTML. And actually, I even put all the JavaScript in this HTML. So everything is inside this file, which is not a great practice. I should have split it into a separate JavaScript file. But just to be able to show everything at once, it is all in that HTML file. So very simple front end in this one. Other ones we have React front ends, but this one's really simple with just JavaScript and HTML, CSS. Then when we get a user question, we send it to the backend. The backend is Python using the Quart framework and using the Unicorn server to run it for production. And that goes to this route here. So this is the chat. This handles the chat stream. That then sends it to the model. And the model streams back the response. And we send that stream back to the server as a streaming HTTP response. So the way you know it's streaming is because we set this header, HTTP header of transfer encoding chunked. And so that we can literally send chunks. And the front end knows that, oh, okay, we're bringing this in chunk by chunk. So the front end will actually get a token at a time so that the front end can show the streaming. So this is the big thing I wanted to show is that if we're building a user-facing application, we want to have that streamed response. And so we want to have some way of streaming something into the front end token by token. So this is the simplified code for how to stream responses in Quart. If you're new to Quart, Quart is just a synchronous version of Flask. So this looks kind of like Flask if you know Flask, but basically, we get the request, and then we send off a chat completion, and when we get back the chunks from the tokens from the chat completion, then we send those back out as streamed JSON lines. So there's a lot here. I've got a whole blog post about streaming. So we'll post that blog post in the chat so you can read more exactly about how to set up streaming with the Python backend and also with the JavaScript front end. Now, I also get asked, why does the backend use Quart? Especially because most people have never heard of it. Most people know, in Python, the most popular framework is still Flask. There's also Django and Fast API. So here's the thing about Flask. Flask is a synchronous framework. A synchronous framework can only handle one request per worker. A worker is on your server who's handling in requests. So that means the request comes in from the user and it goes and it makes the request to, OpenAI, and then it has to wait for the response to come back from the LLM before it can finish that response and before it can handle any new user requests. So that means that your workers are often just held up waiting for responses from LLMs. And you get a backlog of workers really easily. Quart is the async version of Flask. And when we use an async framework, it means it can handle new requests while other requests are waiting for IO responses. So while the first request went off and got, asked OpenAI for a response, it can actually start handling a new request and then send off another request to OpenAI. So this way you can handle way more user requests with way less server resources. So this is really good from a server efficiency perspective, from a cost perspective, right? You don't some people are putting up really big servers here, you don't actually need like a really powerful server if you're going to use async, because then you can handle way more requests. So I just want to make sure that any of you that are building Python backend applications, you need to use an async framework. Okay, you could use Quart, you could use Fast API, you could use IO HTTP, just basic. You could use Django with async. I've got a blog post that compares these options as well. I just want to make sure that you're using an async framework. It's going to get you much better performance. And yeah, I just want to spread the good word about async. Okay, and there we go. It is now 10:30, and we made it through everything. I know that we didn't get to cover every single question, and that we did cover a lot today, but as a reminder, it will be recorded. Also, the slides are available, so you can go through the slides. There's even more links in them than what we shared in the chat. So, please do go through slides, rewatch, read the blog posts. Lots of really interesting things to learn about LLMs here. Also, if you have additional questions, my office hours are in Discord every Thursday at 12:30 p.m. PT. So you can follow the link that we'll put in the chat in order to join the Discord and then hop into that office hours. The office hours are really fun. We've been running them for the last few months. So that's a great place to come and answer any of the questions that we missed today or get help setting up something. And you can also get more Python AI resources from this page here. You put in your email and then it gives you a bunch of cool links. And of course, if you're not registered yet for the rest of the series, you can register for that link there. And if any of you speak Spanish, we have Gwyn, who's been in the chat the whole time. Gwyn's going to be giving the Spanish version of this later today. And you can even watch twice, once in English, once in Spanish. And for accessing the recording, I usually just find it immediately on YouTube when I go onto YouTube after this. Let me find the YouTube link for this one. I'll put it in the chat. It's usually available immediately on the YouTube link afterwards. Sometimes there might be a slight delay, but typically it's available right after. Gwyn's talk is at 3 p.m. PT. So that's in about 4.5 hours. And the slides, let me again share the links for the slides so that if you missed that link, here we have the slides. Oh, and Reactor just posted it. Very good. Thank you. All right, so there you can get the slides. It's on the screen too. All right. All right, so that is what we have for today's session. I hope to see you at Wednesday's session about vector embeddings, and also see you at office hours for any additional questions you have. And I'm really excited. Actually, I'm really excited about the vector embeddings one. We're going to get really nerdy on that one. But I'll just warn you, it's going to be really fun. I think it's fun. All right, everyone. I will see you next time. Bye.
Thank you all for joining, and thank you to our speakers. This session is a part of a series. To register for future shows and watch past episodes on demand, you can follow the link on the screen or in the chat. We're always looking to improve our sessions and your experience. If you have any feedback for us, we would love to hear what you have to say. You can find that link on the screen or in the chat. We'll see you at the next one.